Righto, money miners, we've got an underground spectacular coming your way. And speaking of something else spectacular coming our way, you two are coming with me. The Oz IMM Underground Operators Conference in Adelaide, April 7th to 9th. Links in the show notes for the tickets, $100 off. Bloody using the code MOM100. It's a bloody bargain for the greatest underground mining conference in the world. So, today, for this episode, we are talking underground trucks and loaders, and specifically diesel to battery to hybrid to diesel electric wheel ends, bloody all that stuff. And I've got a couple of subject matter experts with me today to go into this. So over here, I've got my good friend Darren Kwok from Barminco and Perenti fame, and over here, Mr. Andrew Dawson from Sandvik fame. Not just any bloody Sandvik person, the business line manager for the haulage division for Sandvik.
Load and haul, yeah.
Load and haul. I bloody always get that. I remember when I interviewed Mal back in the day, I always got his title wrong. He always corrected me. Right, lads. So specifically what I want to talk about today, so for load and haul. So when we say, listeners, when we say load, that's your bloody boggers that pick the bloody dirt up and then they throw it in a truck, which hauls it. So that's your load and haul. So there's a bit happening in the space with, it's all, currently all diesel combustion engines. There was a talk, a few years ago that we're going bloody full electric, straight to battery. Though there's, in open pits, we've got diesel electric, which is, your electric powered wheel ends that are separate. And then we've got potential hybrid versions. We've just had a underground full battery trial at Sunrise Dam. So why don't let's do some definitions of all those different versions. So may as well bloody ask the person that builds them, who's who in the zoo.
Yeah. So I guess just to start it off, Matty, so Sandvik's been building load and haul for over 50 years. We've got quite a range of classes of equipment, meaning sizes to suit different markets and different applications. Our smallest truck starts at 15 tonne and it goes right up to 63 tonne, which is probably our biggest selling truck in Australia anyway. Coupled with that, as you said, we do have battery electric trucks as well. In Canada, there's a good number of 50-tonne trucks, battery trucks running around. And here in Australia, we've got the world's first 65-tonne battery truck that we were working with Barminco on.
And that was the Sunrise Dam trial that I saw on bloody LinkedIn, wasn't it?
It was. So that's full battery.
Yep.
We talk about definitions. I think making that really clear at the very beginning's important, right? So full battery, no other energy source but that battery at the front of the truck. And then you have hybrids, which is a mixture of both a battery as well as a diesel engine or a diesel generator that charges the battery. And then lastly, diesel electric, where you have an electric drivetrain, but you still use a diesel engine to then turn that into electricity and turns that into an electric drivetrain.
And that's the one I want to start on. I guess it's the first step after full diesel combustion, you'd say. So, and we've seen it trialled in underground, like the old joy loaders, but like just hasn't really been taken up. It's like, so give me some rope here. It's you fill it up with diesel. That powers like a diesel generator, which then sends electricity to independent electric motors on the wheel ends, which are independently powered instead of a normal transmission drivetrain and all that. So, and we've just, I think they've been trialled, hasn't been taken up underground, but now sort of potentially going to be the case. Why haven't they been taken up underground before?
That's actually a really, really good question, and I know that Darren's probably got a little more of a worldly view here.
If you two could argue, that'd really make the views good.
Never.
So,
if I will answer this in the most OEM orientated way possible. So, this type of technology, DE technology, like any other product in any other industry, for OEMs, doesn't matter who you are governed by one thing. And that one thing is demand. If demand doesn't exist, there's going to be a delay in implementing a product or a particular technology. Now, if we go to the question about underground mining, underground mines are very hard and they're very restrictive in how you operate equipment.
Because there's walls.
Because there's walls and there's a roof and a floor as well. So this is a very restricted environment. It's this human nature and to stick with what you know. Diesel technology been around 50, 60 years, and we know it works well. So it's about introducing new risks to an industry, whether those risks are real or they're perceived. They do need to be addressed. There is risk aversion. It's normal. But then by extension, if we kind of throw it over to the contractor side, you don't want to risk production and you don't want to risk getting your development meters either. So it kind of becomes this kind of hot pot of different opinions and just different risk profiles about implementing a new technology. And that's one reason why we are where we are.
Because I assume Sandvik don't do like a monthly reimbursement for the contractor's claim. Like if things didn't perform, you could hit them up for a bit extra.
That's a great idea. That's a
great
idea.
Can you just pick it up what we were
going
to make if it all worked well? And look, I've talked about that previously as well. It's like the first mover theory with everything. Like it's a big and to be honest, that's what the big contractors, the two of yous in Australia, do so well, is that you do take, that you are the future, you're the big dogs, but you do a lot of trials and which, it costs money, it sacrifices production, but to get into the future, you have to do it.
I think one of the questions that it's a simple question, it is why, right? So for the longest time, why would you go to a diesel electric drivetrain? Right, and risk is one of those. We know diesel gear pretty well now. We've used it for a really long time, and we've refined it to a fine art. And really, people thought about emissions, and they said, well, going to a diesel electric doesn't really solve our emissions problem, right? So why would we go to a diesel electric driveline? And
is there a clear advantage? What is the advantage?
I would say that a few years ago, the technology wasn't quite where it needed to be. So the advantages were fairly thin. So you've got the capital increase in the driveline, you've got the R&D, and then you have the risk. So you layer all that together, and it's a really difficult proposition to go forward with. As technology gets better, as motors get more efficient, you have to remember in a surface truck, you had a whole lot of room to stick a really big motor into to do the work. In underground, we're defined by the envelope of the drive, and the motors just simply weren't the power to size ratio that we needed it to be. As technology got better, all of a sudden, we now know that they could accelerate faster. They're more energy efficient, so you use less fuel. They lift faster if it's a loader, for example. And so the benefits are becoming clearer. And as the benefits get better, I think absolutely we want to reduce emissions, but it could just be a better machine. And as you know, as contractors, we just want the best machine. And if it's the best machine, we'll use them. And that's where we are today, is we're looking at what is the best machine moving forward. And it's not just about diesel electric, it's about the best machine for what type of mine site, for what conditions, and that's where we are.
And I assume the maintenance is the big, because I can probably cut a deal here, like while we're here. The maintenance, because the diesel electric versions, I assume you got no transmission, no up box, down box, is that right? And there's probably a couple of other things that are absent.
the PTO might be absent. You could be running that off an electric motor as well.
Yep.
So the idea is, or certainly the expectation is, that these are going to be more reliable machines, less interventions. By
Safer.
extension, it becomes safer because you don't need to touch it as much. There's less things to break. There's more uptime. Then there's that whole flow on to productivity, which is super important for contractors. And just to reinforce the point, once we start removing items from a mechanical driveline and introducing electric drivelines, the expectation is that the lifespan of these machines is going to extend out as well, which is going to drive down your TCO. So Darren made just alluded to a point there about capital cost, which it's the question we get asked. It's probably the number one question. What are you going to do about it?
How much does it cost?
That I can't tell you just yet, but it will be more expensive than a diesel, but by how much we don't know just yet. But the point
It's like
here
a
is
plasma
that
TV. They cost a fortune when they first come out. They're
exactly
cheap these
right,
days.
and now you get economies of scale, and away we go. But obviously the longer the life will drive down your TCO, so the market will bear that higher capital cost.
And so how does it work? So I assume there's a lot of technology behind like these independent wheel ends, getting them to talk to each other, the traction control, like for, slipping when you're bogging, like driving up a slippery decline, like there's a bit that goes into that. Is it different for the trucks and the loaders, or like what's happening?
Yeah, so certainly with trucking, when you turn a corner, one wheel will spin faster than the other, right?
Yeah.
So
on a conventional transmission.
yeah, and same on its physics. So on any truck as well, when you're turning around, one will spin quicker than the other. The magic in diesel electric actually resides in the software to make that happen. So the control system talking to the wheel ends, so you go faster and you slow down. That's where it all resides in. The design on a loader is slightly different. So rather than having 4 wheel motors that you would on a truck, one on each wheel, with a loader we actually have conventional axles with motors attached to those. And the motors are actually set up higher, and then they'll run it that way. So there's still that mechanical, mechanical physics side of it, with wheels spinning around. So it's basically both areas are covered. But to answer your question, it actually all resides in the software.
So is that when you're saying independent axles, are you saying one motor controls the back wheels, one motor controls the front?
Correct.
So
Yes, that'll control the
individual.
axle. No, not on a loader.
Not loader.
But on a truck, yes, it is one motor on
You also
each
have to remember that you have a lot more information on an existing diesel truck. You get to control the motor. And the motor is how much torque and how much power are you making on what throttle position. Right? That's really your control. When you have on a truck, on a diesel electric truck, you'll have individual motors on each wheel. And you now know the speed of each wheel, and you now know how much traction you have at each wheel thousands of times a second. And that's, if you think about how cars have evolved, that's pretty much how much control we'll have in the underground mining world. So if you know the inside front left wheel is turning a little bit slower than the outside right wheel, then you can say, well, you don't need much torque on the inside, you need more torque on the outside, for example, what's traction's available. So we can reduce tire wear. We could actually manage traction. And if you look at a loader, for example, as we attack the pile, we'll know exactly how much torque we can give to the traction that we have, and the breakout forces will be greater. So it's about control and information. So the software, as Andrew managed, if we have the information, we can then drive a whole heap more learning and better control of the machine.
So when you're talking about like lift quicker and break out quicker when you're digging, like what's driving that? Where's the extra energy coming from?
There's a few things. I mean, there's no lag, so there's no rev up time.
Yep.
Right, so you're not waiting for the engine.
Losses through the system.
Yeah, you're not waiting for the engine to rev up so that you can build the pressure to then lift the bucket, for example. Electric motor, an electric drivetrain will say, I need power to the hydraulics now.
Oh, so there's an electric drivetrain going to the bucket as well.
Well, in some cases,
hydraulics.
yeah.
So you're sort of getting like the electrical benefits of going full battery without actually having a battery in it.
There's less things in between where your energy starts and where your energy needs to go to, which means it's faster.
Yeah.
And there's less loss.
What about water? What's the permeability of these these things like because that's the big difference to open pit. You're gonna have loaders like bogging bloody sumps. You got like bogging flooded declines and everything
salty
like
water
that. Oh, bloody salty water. God, if contractors could remove anything from the bloody underground mining environment, I'd reckon salty water would be probably the friggin' top of it. So, look, I assume water wasn't a friggin' afterthought. That's probably the first thing that came up about talking about electric wheel ends in underground. So, what's been put into making these things bloody waterproof?
Yeah, so one is the design of the motors and how we run the harnesses themselves and protect the harnesses. So a lot of this is protected through the inherent design. If we lose, you'll just go back to your example about bogging sumps. One of the reasons the DE loader is designed differently to the DE truck is for that. So we know that miners will bog sumps. So the motors are actually positioned higher than what they are on a truck. The water axles can go into the water, but obviously you want to keep the motors out. So they actually sit up higher, and then it's just the routing of the harnesses and just your standard IP protections. And a bit of common sense too. Just don't.
Well, yeah, you can't bank on that.
Don't high pressure clean the motors, right?
Yeah, I suppose it's not like yous have gone like straight to bloody full electric everywhere. Like Sandvik loaders and all that have been electrically powered for ages, like instead of being hydraulically powered from the sticks and everything. So,
no, that's correct.
But yeah, it's definitely been since a few years ago, like just that step change in thinking. Like we've even seen it in the global EV market, like the rise of the plug-in hybrid. So it's not like going straight to full battery isn't necessarily going to be the only thing. So. But then obviously we've just seen like going to the full end, the full battery truck trial at Sunrise Dam, for a big same size truck as what we're using for the diesel one. So like Kwoki, how did it go? Like the trial, like honest feedback.
I think it went well. I mean, I think the first thing when people ask me about that trial is I always remind people it was a prototype truck. So if you use that lens, we used a prototype truck in production, which almost never happens. Usually a prototype truck goes to a mine site, you do a couple of cycles, you pull it back out, you let the other trucks go back and do some work just to learn. But this truck went in and it did work. And it did work for 6 months that we did the trial for. And it was part of the trucking loop, the trucking cycle. So for that, I think it did really, really well. And we learnt a whole heap, which is the whole point of a trial, which is about learning about the machine. But more importantly, we learnt about the things around the machine that needs to keep it running. You talked about a bit of a cooling in the full battery piece. I think that's because we understand it more. And it's more than just the kit. It's more than just the gear. It's infrastructure. It's mine planning. So when you add that complexity to it, then there's a bit to chew on there. It's going to take a little while for us to understand it. But the truck went, in my opinion, really well. We learnt a whole sleuth of stuff. I mean, I'll give you an example of something we never thought about. We know the truck was going to be faster. We know it's going to accelerate faster. What we didn't consider is when you put one truck in between 10 other diesel trucks, one electric truck, 10 other diesel trucks, you're only as fast as the truck ahead of you.
Yeah.
Right?
Yeah.
And so you could have a good run, but more than likely, as you know, you're going to have a run where you have a truck in front of you, you're loaded, you might be able to do X kilometers an hour, but the truck in front of you can't. So you're just going to do as fast as the truck in front of you, and you won't see the benefit, right? So understanding what the constraints are.
That'd be a tough one to pick in the lead up, wouldn't it?
That's right.
Yeah,
you just don't see that. But now we know.
Yeah.
And then the other one, I love this other piece is, range anxiety. Everyone thinks that you want the battery to be as full as possible, as much as possible, right? Which means you sort of tempted to put chargers everywhere or put batteries everywhere. That's expensive, and develop the charge bays and the battery bays. But actually, you want the truck to be fairly empty at the top when it comes down, because you want the energy from the regen to go somewhere, right? And so you want to come down fairly empty, but plan it so well that when you get to the bottom, the battery's fully charged and you've got a free hit. Then you get to drive back up again. And then somewhere between there and the ROM, you need to put a battery in place, maybe, if the tram is too far. In the perfect world, you might actually be able to get to the ROM and come back downhill again and actually almost close the loop, right? So that's another lesson learned. In the beginning, you sort of go, oh, we might put a battery up the top so you get a fully charged battery. When you go down, you're sort of good to go. But the lesson learned is actually, no, we want the battery up top to maybe be 30, 40%, so that when it goes back down, it's fully charged.
So that whole charging process for like the one you've got at the moment, the full battery one, like say, can it go down a kilometre underground and get up to the surface on one battery without charging? Can it do it yet?
Yeah, so we were ranging over 9K at
Sunrise.
At
the deepest point, it was over 8 for sure. Yeah.
Just one thing I want to point out about this technology. We talk about the payload, we talk about that unit as being a 65-ton truck. It's not. The 65-ton in the back, but the machine has to carry itself.
Yeah.
So we have a battery, a 450 kilowatt hour battery driving closer to 120 ton on a 1 in 7 for a bit over 9 kilometres. So that's a real...
The battery's like 8 ton, isn't it?
Yeah, close to 9 ton. Yeah, correct. Yeah, it's a real testament to the technology, and that ultimately we're going to get there. It's just however long that market adoption is going to take and how ready we are as an industry to bring it on.
So that regen, like say you're tramming down like, I don't know, freaking 500 metres underground, so 3.5 kilometres worth of decline, and you go in at, what'd you say, like 30, 40%. Like, so if you're going down unloaded, by the time you get down there to get a load, like would that be fully charged again from the regen?
There's a lot of, it depends, but it's clearly not 1 for 1, because you're going down empty, you're coming up loaded most of the time. So it's not 1 for 1, but it's so effective that we had the opposite problem. We had too much power. And when you have too much power, you have to do something, but the energy can't be dissipated invisibly. So you have to turn it into something, right? So actually you might reduce performance if you have nowhere to put the power going downhill, right? So you have to turn it into heat. For example. So it's pretty efficient. And once you know what it is, you can plan for it, and it's a science. You plan for it to do this cycle, your cycle loop, and then when you come back down again, you have to be about 40%, and off you go again. Remember, we have control over how much we charge the battery in the first place. So you might not charge it to 100%, right? You might charge it to 80, because that's all you need by the time you get up and get back down again. And that's all done digitally. We have management of that.
Is it just a normal lithium battery?
Lithium iron phosphate, yeah, correct.
Is it the same rule with these ones? Like say, like if you charge above 80%, like the longevity of the battery could be affected. So you should only charge to 80%, or is it the 100% you refer to? Is that the 80%?
We put, I believe we put measures in place so we weren't. Actually, no, we would put measures in place so it couldn't go under a certain charge.
We also couldn't go over the top.
Yeah, we couldn't go over the top.
Yeah,
so
we
there
didn't
is
want
a
to hurt
sweet
their
spot in there.
battery either.
Hey, look, what a beautiful relationship you guys have.
Because we would charge it, right? But the reality is we're reducing its life by charging it to the top. So, the battery is a really interesting conversation, because the more we get maturity and information about this, everyone wants the latest and the greatest, the most energy dense per kilogram of battery, but they're a more expensive battery. So there will come a point where we actually don't want the latest and the greatest for some mine sites because we don't need it. We don't need the energy density. And we might get away with a smaller battery. So there's a middle ground as we understand it more, we understand the cost of the energy more and what we need for different types of mine sites more, it'll be more effective. And OEMs, you know, I have some empathy for OEMs sometimes, Andrew knows, that, you know, everyone's asking them for more, but the reality is we need to understand what we can do with the things we already have before we ask, because more is expensive. So that's where we are now, is we have a whole heap of data from various trials, and then we're trying to say, okay, well, what does that look like for a Sunrise Dam? What does that look like for a smaller mine site somewhere else? What are the, you know, what if it's not a decline mine? What if it's a shaft mine and you're only trucking on the level? So all of those things change the dynamics. If you're trucking on the level, you don't need a massive battery because it's on the flats and you're doing a small loop. You might only need 3/4 of a shift for blast time and you get a new battery.
And it should compound a little bit, because if you're using like a smaller battery, like you've got less battery weight,
Correct.
so you should maybe chew the battery less per size due to less battery weight. So yeah, and what, like, for that truck, options for that truck. So, because I remember we had Shane McClay come in from Entech, and like, you know, his sort of prediction for the, you know, the future of, you know, the what plugins or battery swap or battery charging. He was saying that he probably thinks it'll be more battery charging instead of like having to drop the battery and have extra batteries and cycle them and all that. Like, so it probably applies more to loaders, because you'll have like a loader can just pull up at a jumbo box and plug it in, and or it can, when it goes for a daily, it plugs in for 20 minutes and like recharges itself with 1,000 volt. So like that truck you got at the moment, like say it's run out of juice or something and they've pulled onto a level, like can they actually get a Macy plug from a jumbo box or something and plug it in and charge themselves?
Well, so with the Sandvik truck, the batteries actually come off. So we have an off-board charging system.
I say, so you can't charge that battery while
Yeah,
it's still
you could
on the truck?
if you could. You'd have to take some plates off, but you could if you.
It's doable.
It's doable, but the actual system is designed that you drive into your bay, you put the battery down, you drive out on a smaller tramming battery, go and pick up a fresh battery, and away you go. Then an attendant or the operator will go and then plug that one that battery in, and you just continue on your cycle.
So what about the heat? Like you mentioned about dissipating the heat. Like say you're going down and like the regens recharge to like 100% or so. Like how much heat's actually getting dissipated? Did you notice how much it was? I assume it's probably less than a diesel, like full bloody diesel truck, but is it make things hot?
Yeah, we've got it wrong if we're having to dissipate heat. It means we haven't planned the journey down, right? So if you plan it right, then the problem with dissipating heat isn't there. But we know it's a far cooler mine. If you could click your fingers and have all electric gear underground, we know it'll be a far cooler mine. We know that we'll need less vent, and that the savings in not just vent is also in refridge, for example, for some of the hotter mines out there. So there are benefits to this gear when it comes to being cooler. We did a study with one of our clients, IGO, where a couple of interesting things came out of that study. One was that the cost parity was pretty close for that particular mine. Two, because of the reduction in refridge on the surface for that mine, it actually used less power net with going electric. So that because you're not using the power of the surface to refridge the air to come back down, to cool the air coming back down, that reduction more than compensated for the energy to charge the machines. So your net energy use came down as well. So which then also spoke about infrastructure costs and so on. So there's a whole systems view. You have to look at the whole mine as a system now, as opposed to individual bits of equipment, to look at the value proposition.
Yeah, right. So Okay, so I guess your first intermediate step's what we've just gone through, which is the diesel electric, independent wheel ends. Full battery is the final stop. What about in between that? Like hybrids? Like what are we going to look at? Like, have a smaller battery, electric wheel ends with smaller diesel Jenny on. Is that being scoped out at the moment, or is it like, and what could that possibly look like?
Yeah, so you're exactly right. So with hybrid, it means it's so hybrid is a dual power source.
Mate,
so
I
it's
should
either
put a bloody Sandvik shirt on today. Like it's like
okay.
I work for you, son.
So you it's like your Prius, right? So when you're in your Prius and you pull up to your satellites and the engine shuts, and you take away off in battery. So that's kind of the expectation about what a hybrid technology is going to be like in underground. Whether it kind of gets to that point in practicality is another thing, and it goes back to Darren's comments earlier about the size of the envelope and the size of the machine and trying to cram everything in, and your point about the size of the battery, because there's limitations on what you can do. So basically, we can approach this from two ways. We can say, right, we want this technology to be able to take us up a decline, right? Which is, if we start going down that road, the battery's probably going to be too big for what we want. But if we want to be down on a flat level and we're waiting to be loaded, we want to shut that engine. We want to keep the aircon going, but we still want to move the truck up and down. So for intents and purposes for the operator, they've got a 100% operational truck. They've got the cool wind blowing and they can move up and down and get loaded. When they then are loaded and then they go to the decline, the diesel engine will kick back in and they'll go off that way. So that's kind of, I guess, how we're seeing it right now. Battery technology will continue to develop. There's no questions with that. It's just how long that technology develops to being the size of the battery, I think will dictate how far we end up going with this hybrid technology. And the other question is, at what point does it cut off? If that battery power gets so great or the technology so advanced, when does it become a battery loader? And then you don't even need the engine anymore.
And back to why, right? Why a hybrid is, a hybrid gives us the ultimate flexibility. One of the concerns and the challenges with a full battery machine is you have to somehow get the energy from a charger into the battery into the machine to then do your work. And that takes time. And right now, the way charging happens, it takes longer than you tipping some diesel into a tank. So that's the challenge. So as charging speeds increase, then that delta changes again. And so the question is, why do we want a hybrid? It's because we want flexibility. Diesel has given us a shift's worth of flexibility and we sort of got used to that. And right now, battery has taken a bit of that away. But as that flexibility increases because battery density gets improved, charging speeds gets improved, one of the things that I've always spoken to Sandvik about in the last 2 years on some of their machines, for the same size battery, the energy density has gone up by 20 and 30%. That's just pure technology. And so in 2 years, if that can occur, imagine what it's going to be like in the next 2 years, because it's exponential.
Yeah.
And charging speeds go up. The real limitation here as well is how much power do you have on your mine site? Because they're not talking about one bit of gear here. You're talking about multiple pieces of equipment that all are demanding energy from somewhere.
Yeah.
So we need to think about this as energy flow. And we need to start thinking about our mines as, we think about them as material flow. We've always thought about that as material flow. But in an electric mine, you start thinking about energy flow as well, because energy flow is also material flow. You need to have the same thing.
So if you think of it, okay, what it is now, like you got diesel trucks and loaders underground. You've got diesel generators on the surface, which provide the power to all the mine site. Say if you're like converted to full battery for everything underground, so you're saving on diesel, filling them up, but you're using diesel to charge them. Would you use the same, more or less, diesel to recharge everything full battery than you would if it was all diesel powered machinery?
Really interesting question. And so we're doing at Perenti, we're doing a lot of work with our customers at that PFS, DFS stage of studying the mine. So we know how to draw up a mine pretty well as a diesel mine.
Yeah.
But we need to learn how to draw up a mine as an electric mine or hybrid mine, for example.
Yeah.
And that will answer those questions because a generator making electricity is often more efficient on fuel than a motor driving a machine.
Yeah.
So a genset will sit there and hum at 1800 RPM and make power, which will then go into your battery and use less liters per kilowatt than if you're using that same motor in a truck that has to do 2000 RPM and fluctuates up and down. Right. So there's efficiencies in the system. Again, back to the whole systems view. There's efficiencies in the system everywhere, and you got to capture those. And as you add the 2% and the 5% here and there, it starts stacking up to the value proposition. And that's what the work is right now, is trying to understand for what mine sites, is it a greenfield, is it a brownfield? Can we avoid a vent rise at a greenfield level that will save us some capital costs up front? All of those things add up to the value proposition of electric mines.
And I assume the tendering process is gonna, that'll probably change because you're like things you've just described are all like, cost benefits to the client. So it's like, whereas the contractor wants to bloody make the money, but they've got to, like, when's that cost benefit flow onto the contractor like today? Because they've got to outlay the capital for potentially more expensive machines. Will the schedule of rates change? Like, will it be, higher dollar per TKM and a higher dollar per bloody ton move for a bogger if you're using that type of equipment? Like, how's it going to flow into your pockets?
I mean, at the end of the day, we all want the same thing. We want the safest, most productive mine.
I suppose it gives you more chance of winning a contract too.
It also means that we get to be more collaborative with our client, because end of the day, we have to think about the processing plant when we didn't have to before. We have to work together closer. That's the ultimate conversation here. Is we have to work with everyone in the value chain to make sure we produce the best mine possible for an electric mine. Yes, there's a whole heap of commercial machinations that today don't work in the electric world, but we'll get to that. If this is the safest, most productive mine, then all the people that I know around us, including our customers and ourselves, we'll come to a place where we can make it work, right? So I think the question now is, okay, how do we define it? Even down to KPIs, TKMs, work on engine hours and idle hours. Electric machine doesn't idle, right? So all of a sudden, all of the maths don't add up anymore. Yeah. So all of those things we still need to sort of define, and it has to be believable, and everyone has to have a trust in it. But once we get there, it'll just. I do believe at some point, if we do this right and the technology goes the way it should, it'll just simply be a better way, a better machine, that also has less emissions and is safer and so on. So it is a win-win if we get it right. Yeah.
So Andrew, what about like Hemi, for instance? Like you've got, that's probably one of the more greenfields, like, potentially big underground projects coming up. I assume if Northern Star's bought it, they're going to take it bloody underground. You would assume so, eventually. So that that has the potential to be designed to take into account a more battery green friendly load and haul system for that mine. What sort of, like, for companies like that with a greenfields project, like, is there much at the moment, like, collaboration between them and OEMs about the design, like what machines might be available then, how's it going to work, like all that?
Yeah, there's a lot. So we actually have a dedicated applications engineering team. So they will go and work with companies like Barminco and others, and they'll start planning and working out what the mine should look like. That will be, as Darren was saying earlier, the best thing to do is to haul down. Whether or not that's a practicality, I don't know. But it's more around charge bay design. So all the runs, so during the life of the mine, it's all planned out in stages, and then they can see where charging bays need to be at any certain point. So the cycle will continue on. So because Sandvik uses offboard charging, we can just continually take the charging infrastructure. We'll just follow the mine down. It's no big deal. And then that'll just be engineered with the applications team. And then they'll have a design from the start.
Sounds bloody easy, doesn't it?
It does, yeah. You just got to make the power. That's the thing.
Well, we've definitely harped on enough about the rocks and moving bloody rocks. I reckon yous will have plenty of other stuff in your bloody big booths at Underground Operators Conference. And so what are the other bloody, big ticket items we'll be looking to we'll be seeing this year in Adelaide?
So we'll have the LH518IB battery loader. So that will be a showcase in our booth. I think it's probably going to take up the majority of the real estate.
God, how you get all this shit in there when I see it's like a bloody, I don't know it's like a Walmart warehouse when it's all getting put together. There's forklifts and shit going
mats everywhere to drive on.
So that's the full battery loader, is it?
Yeah, correct. Yeah. So that will be prepped and ready to go, and we're excited about that. And we'll have various other digitalisation and remote monitoring areas around. There'll be a big focus on digitalisation for us this year.
Very good. What about in the Perenti Barminco tent? Or is it all in one tent?
I don't know where it's exciting as having a big bit of kit in the middle of our stand, but Mick Ridey, our Vice President of Australia, is doing a talk at AusIMM.
Oh, is he?
Yeah, underground. So to the point of today, which is about collaborative contracting. The modern contractor is about working with people, partnering with folk. So he'll be doing a talk on that. But really, these events are an opportunity for us. So we bring a whole heap of folk from ops and from functional support services like myself and my team are going along, because for us it's an opportunity to talk to our customers, and importantly, it's an opportunity to have a look at the rest of industry. What's everyone else thinking and talking about, and how can we build better outcomes by just having those conversations over a beer or at the stand? Because often that's where, as much as Andrew hates the thought of it, we talk to other folk in the industry.
Yeah. I reckon he's just trying to make you matey. I don't reckon he'll cheat on you like that.
But yes, it's for us, it's learning, it's sharing what we're doing, and also it gives us a chance to sort of take the temperature of what people are thinking. How can we help, and how can we work together and get this thing moving?
Very exciting, very exciting. I knew to be advocates this as well. Like, mate, if you're a young person in the mining industry, like if you go to this, like you learn about the bloody past, present, the future of underground. Like you get to meet friggin' any company, who runs the companies, bloody like. Good prezos, it is such a good learning ground. I wish I went there at a younger age. I was too busy socialising and not thinking about mining. That's all I think about now. Anyway, thanks heap, lads. As you can see, I followed the question list diligently, as you knew I would. Anything we missed?
Nothing from my side. I think we'll get there. I think we're learning. I think diesel, electric and hybrids are a stepping stone. It'll teach us and our people how the equipment works. But we're slowly learning and we'll slowly get there.
Can't thank you enough for coming in late on a Friday. And, mate, get your bloody tickets to Underground Operators Conference. April 7th to 9th, link in the show notes. $100 off by Money of Mine. Exciting stuff.
Thanks, mate.
The information contained in this episode of Money of Mine is of general nature only and does not take into account the objectives, financial situation or needs of any particular person. Before making any investment decision, you should consult with your financial advisor and consider how appropriate the advice is to your objectives, financial situation and needs.